Positive acceptance.
Acosta. Today we're going to talk about building SecOps AI agents with Splunk. A little bit about me. So I was alumni affairs or administrative affairs at Swift in 2019. I'm a CPP alumni. I was really involved with FAST as well as Swift. Although I'd say there was like a couple programs that I focused on in my later years. Um, Avid Splunker. So I've been at Splunk for almost 2 years. I have around 7 years of experience. I started in venture, funny enough, looking at like product analysts, then moved into technical role, cloud engineering, before AI really came on the scene. Back then, it was a lot of chatbots or NLP or stuff like text to speech, speech to text. So if you've ever called the bank, Wells Fargo, Bank of America app, and it's a bot, I'm sorry, I built that. Hopefully it directed you and routed you to the right person, but yeah. And then I put AI enthusiasts and therapists because honestly, I think every AI needs a therapist. You're really building out this prompt. Um, you're nurturing a relationship when you build out anything in AI. And honestly, I feel like most of the time when something's broken, that's kind of what I'm doing. Just digging through, figuring out what the problems are, how to make it better. So keep that in mind. So in terms of contents, we're gonna set the stage. So I'll talk about that shift. I spoke about how things used to be chatbots, now they're agentic, what that means. We'll look at how to build out an AI agent, what the exact components are of AI agents. I think as you progress in the industry too, there's going to be a lot of like agentic SOC or agentic X, and I think it's important to understand what really designates something to be agentic or not. Not the marketing term, but the technical term. So we'll create those definitions here today. Then we'll talk about MCP, which is Model Context Protocol. Probably everyone's heard about it, so we'll just talk about how it actually works. I'll look at MCP security, so some of the security considerations you should look into when looking at employing MCP. Then I'll have a demo. Then we'll look at some resources and then the hands-on workshop. Keep in mind the hands-on workshop because we're kind of pressed on time. We might have to go through a little quicker than expected, but I want to provide resources so that if you wanted to do this on your own time, if you wanted to play around with the Splunk environment, there are resources to do so. Okay, so let's begin on this agentic shift. So everything was chatbots, then we got agents, and now we're looking at this internet of agents. I'm in the industry. I've been in the industry for a few years. I'd say the last step from agentic workflows to the internet of agents is very convoluted. I don't think a lot of companies actually are able to employ this in production unless they're, CSPs or really big companies that have a lot of technical know-how. But the biggest shift you're going to see is this shift between individual assistants. So assistants help in a specialized task. Think about the Wells Fargo chatbot, right? It's really just helping you direct and route your call. If it's like a checkings or banking question, if it's a customer service or HR question, right? Very simple. But then when you look at agents, and again, MCP is a keyword you'll see over and over. It's just a protocol, very similar to like REST APIs. It's just a protocol that won in the battle. Um, but this allows for tooling, and we'll talk about why MCP kind of expands the aperture of what an assistant or chatbot or AI can accomplish. And then in terms of the internet of agents, so just think about this like network of agents. That's the end goal. So instead of having a chatbot that's routing between banking and checking and some of those services, wouldn't it be cool if we had specialized agents that were very keen on specific tasks? So maybe you have an HR agent, maybe you have a banking agent. Maybe the banking agent could, revoke a credit card or it could process a payment for you. And it could do that autonomously. Obviously, human in the loop is probably required, getting a human authorization off of it. But that's the future we're looking at. And I think a lot of people kind of say, oh, this is like the internet in the late 80s, early 90s, right? Where before we didn't really have like browsers like Google to search through all these different tabs or websites. And I think that's going to be the next progression is we're going to interact with our AI or chatbot more than usual. My girlfriend always says, "Did you ask the wind instead of ChatGPT, or did you ask yourself or your previous self?" So I'll be honest, I rely on ChatGPT more than I like sometimes, but I think it's important to understand like the bias and how these things are trained, how they're developed, so you can understand when you should use it and when you shouldn't. Okay, so what are agents? Two key things to keep in mind when we look at like AI agents, I guess I have to stay by the mic. But the difference between like an AI workflow, so perhaps you've developed a workflow, a playbook of some sorts, a run book, um, right? A script or something that connects to an LLM. Well, that's a workflow. And the difference between that and an agent is that you need to be very prescriptive. Perhaps you give a list of available run books to the agent excuse me, to the LLM, and then it can designate which one would be appropriate. And you're relying on a generalist model, and perhaps you're fine-tuning it with like, some sort of fine-tuning mechanism, or you're augmenting the data that's coming back with like a RAG pattern. But the key concept there is that you have to be very prescriptive. You have to define out, just like programmatic code, where you need to put all the if-else statements, you need to look at conditions, edge cases. That's really what a workflow is. But in the world of agentics, there's a spectrum. So we could be really prescriptive or we could be not prescriptive at all and give it full authority, right? And that goes into goal oriented. So usually when we type a prompt or we ask it to invoke a specific response, we just set the objective. We don't have to be prescriptive and explain every single step, every single process. It'll designate what those subtasks would be. And then adaptable. So this is the hardest part about agents and why a lot of times we see it operationalized in a dev environment or sandbox and not in production scale, is that they're adaptable. If you write programmatic code, and if you don't think of an edge case, you might have some bugs in it, right? Um, but you won't check your code file unless someone is messing with your repository and sending PRs, right? And it won't change. That's the issue with agents, right? Is that their prescriptive path can change. They're adaptable. So then how do we maintain them? And that's where guardrails come into play. That's where limiting the level of agent control flow, which is another slide I'll explain, so we can designate solutions that are more constitutional to our objective, right? Instead of building out and expanding the scope. And you've probably seen that a couple times, right? Maybe you ask ChatGPT to help you on a homework assignment, God forbid, right? And perhaps it gives you a really good response, and then you're like, okay, but add in, some information from these websites, and then ChatGPT can be difficult to understand. Is it true or not? It's the world's, best bullshitter. I'm just going to be honest, right? It's hard to know if it's accurate or not. And that's why they're providing external links, resources, right? But that's talking about adaptability, right? And then autonomy. So again, this is the holy grail. Eventually, what industries and companies want, going back to that banking example, is if I can replace a call center, if I can replace some of the checking and routing, some, minor tickets that are going to the fraud department, and I could replace that with agents who could autonomously do that. And then I just monitor them. I check in on them and say, look at like run book history, tracing logs, and say, okay, did they do this right or not? Is there an error? Then I'm reducing a lot of like tier one level work in any industry. But this is also tricky too, understanding when systems should be more autonomous or less autonomous. And that's why I don't think AI is here to replace us. I think it's here to transform the way we work. Okay, and then in terms of agentic design patterns, so again, tool use, you'll probably see this a lot with MCP. Reflection, so maybe you just have an agent, remember we were talking about tracing and logging, that'll look at conversation history, it'll look at actual incidents, and it'll look at what was the tasks that were set in place, and then run a review and say, is there data drift? Is there model drift? Is it appropriately handling these requests or not? So that's what you'll see in production is that you'll probably have an agent and then you'll have like almost like a coach. like a coach agent that's monitoring, making sure that it's performing at its best. Collaboration. So again, we see this a lot with MCP. MCP is just a model context. So if we can add in more context from other services, that's where MCP comes into place. And then planning. So going back to the objective component. So how do we build an agent? Step one is we need to set the objective, right? So is it HR? Is it security? Is it IT ops? What is it for? Step two is we need to choose an LLM. And understanding how LLMs are fine-tuned, trained, we can employ this. We could change this to foundation model, right? Because we might build a multi-model agent. Maybe we want like a time series foundation model to look at time series data. Um, this is a very simple reflex agent, but keep in mind that you can definitely have agents that are multi-model that can switch between models depending on, the issue or incident at hand. And then tools, so APIs, MCP calls, and then define the type. So again, simple reflex. This is a very simple like it's known as a React agent to advanced learning agents. And learning agents, they can be a mix of different agents that come together. Maybe one is focused on planning, one is focused on tool execution, and they create this almost like transformer, right? That's able to accomplish tasks. So this reasoning loop, right? Really what we see is we see perceive, then we see reason, act, and then observe. So that's the loop that an agent's going to go through. They're going to perceive, then they're going to set some objectives, then they're going to decide how to act, either by using tools, and those could be any of these, on the environment, and then they observe, they reflect. This is the biggest component about an agent, right? That designates it as an agentic system versus just an AI workflow. Is that an AI workflow, it'll perceive, it'll reason, it'll act, but it won't observe. It won't like look back and be like, okay, am I doing this right? And we'll explain how we add that in. So we're looking at context, cognition, and action. So this is the agent control flow. So again, this is, you could have programmatic code that does the same thing, but instead of relying on, some algorithm, we're going to rely on an LLM to denote if we should go from step one to step two or step one to step three. Or it could be fully autonomous. And this is, again, like the very end of the spectrum. And this is where we don't even create steps. So the objective might be, um, I'm writing this essay and I need to, add in 5 sources, blah, blah, blah. It needs to be about the specific topic, perhaps on how chatbots are changing the banking industry. Can you write it for me? So all the information that I'm providing is in the prompt, but there isn't like a specific step. I'm not saying use, Wikipedia, pull from this document repository. Um, so I can go about it in a multitude of ways. It could go to the web. It could look at your directory if it has access to that. It could look at your context and conversation history and be like, okay, what have I written other essays for this user? What style of, writing would they prefer? So think about that. It really has like free flow to go through any iteration of steps. Um, and the best way to explain this is that we have human driven and then agent driven or agent executed. So this is the spectrum of control. And think of, right, LLMs are smart, but they're kind of dumb, right? It's kind of like a young child trying to execute a task. So here, we're being very prescriptive. Maybe we tell the child, okay, I want you to go to the bread section and get the white bread. Very specific. Step one, step two. Or I just say, can you get me some bread? So it's like, do I get bread at, you know, the grocery store or do I go to the park? Right? They have to think. So that's the difference. And then agent components. So there's a planning router, the skills and execution, and then the memory feedback. And I understand that everything says one. That's a file format error from PowerPoint to Google Slides. So it could be function calling. So again, going back to that step one, step two, it could just be code. And then from those programmatic codes, it's going to choose one or the other. So we're giving the LLM the planning and the reasoning, but we're not giving it the ability to create the actual execution, right? Or it could be intent classification, where the LLM will just say, okay, the user is expecting me to do X. Let me see what's available from the tools that match this objective. And then from there, I'm going to decide which tools or which steps to use. Skills, again, alum, API, MCP, and then feedback, right? So feedback and memory loop. And that's what it looks like. This is a high level architecture diagram of what you would see in an agent. So we have data coming in, the perception module. Again, it's a module, right? So an LLM could exist here. It could not. It could also just be programmatic code. And honestly, we probably want it to be more prescriptive than less prescriptive. Usually, if you're in an industry, right, think about COBOL code and some mainframes. They've been there since the 50s. Um, and maintaining those systems is like the key reason why COBOL is still being used, right? Because it's running, it's operational, you don't have to change it. And the same thing with AI. If you have to constantly come in, fix it, tweak it, then it becomes more pain than value, right? You're losing a lot of value. And then memory and context. So this is stateful or stateless. We can add in more memory. We could add in like knowledge artifacts. We could give it like lookup tables to say, we could give it pre-prompts. So those are all concepts there. And then planning and reasoning, the decision-making module, execution layers, so that could be MCP or tools, and then the feedback and learning loop. And this is the biggest thing that a lot of people miss, is that if we build out an agent, but we don't have any feedback or learning loop mechanism, um, then we're not checking in, right? We're not being a good coach. We're not being a good parent. And that's why I'm saying AI therapist, right? We got to be like, hey, how are you doing? Almost on a weekly basis, checking on them, see how they're doing, see what they're accomplishing. And that's why you really have to maintain this relationship with your agent. Quick slide here, some multi-agent architectures. This is just giving you insight that there's a way to connect multiple agents together. They use the A2A protocol. This is developed by Google. There's other ones, again, just like how there's other protocols for MCP. But the key thing they think here is that it could always be vertical. So you might have like a orchestrator agent and then sub agents, or it could be horizontal. So agents, there's no hierarchy. One could call the other, the one could call the other. There's no order of like orchestrative, there's no hierarchy to it. And then in the agent card, right, we have some very similar to MCP. All MCP does, if you ever look at it, it's basically an MD file and a config file, and the MD file explains it's kind of very similar to like an API endpoint, right? It'll explain the endpoint, what payload you can receive, what payload you should send, what response you should get back. And then, it's just giving that information to the LM or whatever AI that you're connecting it to, that those endpoints or they're more called like skip tools, are available for the LM to accomplish that task. So that's what the MCP layer is. And then in that MCP, we can have different tools and APIs. So the pro is that this is very scalable. Um, this is super efficient if you have agents that can manage each other. The con is it's really hard. I've yet to see a company that's really operationalized this at like a grand level. Probably Anthropic and some of the AI houses have a better grasp of this, but in the industry, it's very difficult to build this out. And the biggest issue with that is that you really have to understand your environment, you have to understand your systems, and you have to be a good coach. You have to be a good coach to understand how to put your agent in the best place to perform, and that's how you should look at it. Okay, so building an agent, model selection, tool calling, and guardrails. So size versus capabilities, use case, context window, observability, thinking about how do we observe and monitor the agent and its interactions. Guardrails, right? Really important here. So human in the loop, that's usually a really big one that you should implement anywhere you can. And access controls, permissions. Again, so the way that we'll work with our agent in our hands-on workshop is that it uses a token, and that token is associated to user. So keep in mind that a lot of MCPs can be different. They can use different, OAuth or bearer tokens or whatever type of authentication system. But usually they're permeated to a specific user. So each user is associated to that agent, and then the agent has access and permissions relative to that agent. I mean, relative to the user. Oh yeah. Well, I know this is a cybersecurity conference, so what does that have to do with the SecOps agent? So here are a couple very low-level AI agents around security. What I did underneath each title is I listed the available tool. So if you wanted to go home and try it on your own, just make sure you have these tools accessible in your MCP server. And the first one is risk-based alert triage, right? So this is a big problem. Alert fatigue is a problem that if you worked in IT or any ticketing system, really, you might endure. But what this allows, and ES is just enterprise security, it's a Splunk premium app, is that it's able to look at an incident and then create an SPL from it, right? So this is really looking at the ability for an agent to be goal-oriented. So it can look at maybe correlating IOCs. It could look at developing SPL or its own searches, and really we're giving it just ability just to go through and say, hey, there's correlated alerts here. Is there more investigation that can happen? And we can expand upon it. We could add like MITRE attacks or like playbooks, or other things to it. So it could go through and triage alerts. Um, and then anomaly triage. So there's an application called AI Toolkit that's also a Splunk premium app. And really what it does is it enables you to build out algorithms, machine learning modules, statistical models even, um, and then apply those in across like a Splunk index to see if there's any anomalous incidents. So from there, we're able to detect anomalies, which you could do with a scheduled search, right? But the AI component is that it could perform this in an iterative manner. So it could look at using a bunch of different models, right? So maybe it has a couple baseline models. Maybe it uses a machine learning model. Maybe it uses an LLM. And that's the power here with an agentic system is that it can iterate and improve versus, if we write bad code or if we write a bad alert or a scheduled search and it doesn't catch anomalies, well, we have to go back. We can do, some scoring to figure out how well is it performing, and then back to the drawing board, we make an iteration, right? In this case, an agent could do that step for you, and it could iterate, just try to improve better. You give it the objective to reduce anomalies or to improve its detection capabilities, and it's going to try a bunch of different things. Incident scoping. So again, we're trying to see how broad maybe an attack is, so we can look at mapping lateral movement. So in here, we're looking at indexes and index info. So we're just giving the agent the ability to scan across indexes and say, okay, perhaps this IP is a bad actor. And I find this IP address, performing some operation within this Windows event log. Let me look at these other indexes to see how far, how lateral, what's the blast radius. And then the last step is just continuous monitoring. So again, if you have agents that can run autonomously, you could create like SPL searches, scheduled searches, and it can do it in an iterative manner. And the cool thing about this too is that it could create like an alert, it could create like a scheduled search from it, and then it could go back. So instead of you having to like run these or alter them, right, just think of all those variables that might be in those systems. It can do that on its own. So it's kind of just like a tier one, security analyst in that way. It'll just perform very basic level, maybe give summaries of what's happening. So yeah. So I'll go quickly through these, unless you want to learn more about MCP, but just keep in mind it can be an agent or a MCP host. Today we'll download a host. Each server has different skills, and those tools allow you to expose, very similar to API endpoints. So again, MCP, there's a client that connects to the server that connects to the tools. So the MCP server, in this case, that we're going to use is Splunk MCP server. It's a gateway. So there's some authentication and permissions baked into those systems. And then here are some examples of some MCP client or hosts that you could use. So Cloud Desktop, which is what we're going to use today. But really, they're just integrating an LLM to an environment to give you access to an MCP server and then expose certain tools. So this is how it works. Trigger agent, It'll prompt, look for available tools in LLM. It'll request all the different tools. So the host will say, okay, from my config, what clients do I have? It'll list all of the different servers it has. Then the servers will push back, send the tools, and then it'll evaluate the response. So this is the step where the LLM is performing some of the planning and reasoning, but also remember the observation. So perceive, reason, act, observe. So it's observing, it's evaluating the response. So if you ever ask Claude something, it's like thinking or checking or like finishing up. It's really doing that. It's going back to your original prompt. It's looking at the tasks that have been performed, and it's doing this self-evaluation. Am I meeting the objective? Is there something more I can do? So it's trying to answer it to the fullness of the user's input, right? Okay, and then in terms of MCP security, so this is something really important to think about. Um, Often when we're operationalizing and using MCP, a big question comes up, well, like this expands and creates more attack vulnerabilities, 1,000%. So it's important to think about the first one is tool poisoning. So think if you infect an MCP server and then you create like a fake tool or something. Maybe the LLM is trying to connect and use a run Splunk query, and we give it a fake tool that's run Splunk query. And maybe there's some malicious input or information that's being passed into there. Data exfiltration. Um, so this one's a little different. We have an agent and a client versus here we're just looking at an individual like host, LM, and server. So the agent becomes the bad actor in this case, not the host. So we don't infect the server and then try to infect the host. Instead, we're infecting an agent. So maybe an agent is trying to filter out some output, get some information from the MCP client. Okay, and then here are two different command and control scenarios. So one is the rug pull on the right, and then the one on the left is just the more basic one. So again, command and control server communicates with an agent, and then the client, we have a compromised MCP server. So we're trying to isolate specific tools. We're trying to like isolate this MCP client, and then make this agent unable to connect with the original MCP server and then kind of like flip them out. And then the second scenario, what we're doing is that we have a tool. So we have tooling that's appropriate, that's valid, that's been validated. And the way this works is if we go back to the MCP connection, right, we saw that there's that initial call. So it's almost like an authentication. So when that initial call happens, it'll say, okay, this MCP server is legitimate. These are the tools that are exposed. Everything's good. And then what a bad actor would do is that they would infiltrate where the MCP server is hosted, change some of the tools that are available, make them malicious. And then the LLM has already done the investigative work to check that the MCP server is legitimate, but now I'm poisoning it. So it's a rug pull in that way. And then this is the framework of MCP. So in the client, there's really limited options, right? It's really more just like authentication and tool verification. But the server is really the biggest attack vector, right? There's a lot of ways to manipulate, to exfiltrate a server. Um, and I think, with if you make your own MCP client, you can make your own. If you just use the protocol and then build out your own authentication, build out your own gateway. But you're gonna have to think about all of these other components to keep in mind when you're looking at how to make it secure. Or you could use a provider's MCP server, and sometimes it's cloud hosted, so then there's some cloud protection in that manner. And if it's provided or maintained by a specific vendor, they might be protecting it in that way as well. So that keeps in mind that this MCP server that Splunk is providing handles the server and all the config. We just don't handle the client. So whatever client you have, if it's Cloud Desktop, if it's Gemini, if it's Google Anti-Gravity, or if you're building out like an agent builder like Crew AI or whatever agent builder system you use, you would have to think about security risks in that data, right? Not so much the server. Okay, so I'll go through this demo. And in this demo, I know we have like 15 minutes left, so I'll try to keep it brief. But this is what I built. So I built out the SecOps agent. I'm using some Cisco products here too, secure endpoint and firewall. And then I have an MCP server, and then I have a machine learning module. So what I'm doing is I'm looking at ES, looking at notable incidents that are coming into enterprise security. And then from there, I'm adding in context like runbooks on how to appropriately like triage or handle these incidents. It'll look at creating a model, like a machine learning model, to determine, okay, which environment, which indexes are, the incidents actually happening. So validating the incident, the notable incident finding. And then from there, it'll run, if it's like a high level, it'll secure the endpoint, it'll update the firewall config, and then it'll run a SWORD playbook as like a precautionary measure just to add in, some updates to the environment. So that's what it looks like. Let's see how this goes, sharing. Can everyone see my VS Code? Okay, cool. So this is the app. This is how I built it. So this is within LangGraph. Just gonna copy the notable incidents here. Then I'll go back to oh, this environment. So I'm just passing in this notable incident. And at the end of the workshop, in the next 10 minutes, I'll let you try to build something just with Claude. But going back, right, productionizing like a SecOps agent, we want to be as prescriptive as possible and give an agent, we want to be very thoughtful in how we apply autonomy, how we apply agent control. So in this case, I've like really developed like a three paths. So it's very similar to that first example where we have step one, step two, and then step three, and it'll choose. In this case, what we're allowing is I'm giving the LM the ability to perform some reasoning. So it's looking at this notable incident. It's using this MITRE attack and some documents that are explaining, what this incident is basically saying. So I'm fine-tuning the LM in that manner. And then from there, it's going to grade it or give it a ranking if it's high, if it's medium, or if it's low. And if it's high, then it's going to go through a certain step or workflow. If it's medium, it'll go through another one. And then if it's low. So we'll just run this and you can watch it in real time. So we're at the analyze incident step. Let me just go back. So you can see we started off. Now we're connecting to analyze incident. Now I jump to assessing the threat. We'll just move it here. So depending on if it's like high, medium, or low, it'll go into a different workflow. So it looks like it decided it was low and it just ran the SOAR playbook. But if it was medium, I don't know if you could see this, but it would isolate the endpoint, then update the firewall config, block the firewall, then hit the run the playbook, and then save all that context, and then end. And we can see, oh, it actually went through the medium step. I just didn't see it because it was so fast. So we pulled out some MLTK models for baselines. We ran these to determine if there's anomalous activity outside, right? So we're looking at the blast radius. There's an incident. Then we're looking at relevant indexes and trying to determine, is this malicious IP operating within these indexes, yes or no? So that's what it's doing here. And it's looking at different IPs that are suspected and then creating baselines and determining, is it operating, and it could be like login attempts or stuff like that. After it was determined that this threat assessment was high, it did some analysis from there. And then the two next steps are that it isolated the endpoint. So it pulled out some IP addresses that were malicious. Let's see if I can find the job with the IP. No, might have been in the threat assessment. Yeah, so we have these affected systems. So it isolated those endpoints. And then it updated the firewall config to silo those endpoints, right? To not give them access to any other systems or services. And then after that, it ran this SOAR playbook. So this Microsoft Defender playbook that was pulled from another MCP, which is Atlassian. And then it saved all that context. And yeah, so now we have this agent that performs some security operations. If it's high, it can even run some automations. And the cool thing is, if you think about it, right, if I was an analyst, I would have to log into firewall, update those configs. I would have to pull out the malicious or bad actor IP and then isolate the endpoint manually. Versus this system does it all on its own. And there's a couple things to think about. I've given it the full capability, right, to determine the ranking, the severity. Would I want something to do that in production? Probably not. I would want like a human in the loop to authorize it and say, okay, yeah, this is severe, this is medium. So keep that in mind. Okay, cool. So I think we could go on the hands-on portion now, but I'll open it up to any questions. Anyone has any? Yep.
So, uh, well, when the AI detects like a cybersecurity like bomb, how the how does it like determine like which of the which issue it is?
So you're saying if there's a cybersecurity, would you say prompt?
Or like an incident?
Yeah, yeah. So I mean, in this way, right? So I have this analyze incident node, and the way that LangGraph works is, remember we're looking at multi-agent architecture, and that could go like horizontally. It's not vertically. LangGraph versus LangChain, which I'm sure people have heard of. LangGraph is very similar to horizontal, so it can jump between different nodes. This lane graph, so you can load in specific graphs. I loaded this graph as a demo graph, but it could go in any order. But the analyze incident, that node is performing that analysis. So it's looking at the incident. I gave it like a couple different like knowledge artifacts, one on MITRE attacks, another one's on, there's like a threat hunting playbook that Splunk developed. So I gave it all this additional information. It's looking through those documents to find out, okay, of this notable incident, what is it? Um, what is it asking for? And then from there, it determines, okay, it's this specific attack. I can't remember what this one is. Can try to find it. Good system. Yeah, so unusual outbound network traffic patterns, suspicious external domain connection attempts. So that's what this attack was, or not attack, but anomaly is, right? And then from there, I think in the playbook it said if this occurs, you should do an investigation on these indexes. So then that's where it started developing like the anomaly detection to apply to look if there's anomalous activity, and then going through the next series of steps. Any other questions? No. Okay. How many people have Claude installed on their laptop? How many people brought a laptop? Okay, cool. Okay. How many of you have Claude installed or MC? Okay, cool. Has anyone worked with the like the developer settings on MCP? I mean on Claude? Okay, let me show you that real quick because that's pretty cool. So let this load. I think I need to change this. Okay, so this is my Claude, right? So if I go into Claude, if I go into settings, there's this developer tab. Really, Claude has expanded its capabilities. It's kind of amazing. Like a couple of months ago, you couldn't create a PowerPoint, um, other than like these like really small companies that were developing like a PowerPoint tool. Now you can create PowerPoint slides within Claude, and there's even an option to add in like a tooling or component call to add in Excel or PowerPoint. So you could build PowerPoint or Excel files on your laptop. So it's worth checking like all the connections and the apps that are available. But in the developer, we have this developer tab. We can hit edit config, and then it opens up this JSON. Um, for everyone here, it's probably very familiar to what you've seen in like a REST API config. So we have an endpoint. This is my endpoint, my header, and I'm passing in an authorization, and I'm passing in this bearer token. These are some other parameters that I'm passing. But keep in mind, so I'm creating this definition, and I'm passing in this token to connect to the server. And it should be running, right? So if it's running, it's connected, and I can even view the logs of any. Again, it's very similar to like REST, if there's been any interaction with that MCP server or not. And if I go back to chat, let's go back to chat. If I click here on add files, there's the connectors, and then in here you should see Splunk MCP server. I don't think it's connected. I'd probably have to create a new token to authenticate. But here you would have access to different MCPs. And the cool thing is I can create projects now. So if I wanted to create like a co-working tab, I could work in a folder. So say I'm creating code or I'm building out an agent, I could build that right in a certain directory, add in some MCP. And this is good practice too, right? Because if not, then it's all correlated to chat. And the biggest thing with Gen AI or with agents is you're looking at context manipulation. So what context do I provide to the LLM? If I provide like all the history or like root access, it might be really good. That's a crazy security risk, right? So how much context or information do I provide, depending on like your goal? Um, so yeah, that's kind of what it looks like there. Um, so within your environment, right, if you wanted to go to, you just go to show and you could log in and create your own Splunk account. From there, you could build a workshop. You could build out the AI assistant workshop. I'll show you which one it is once it loads. So you could do this at home. So you do this AI assistant for SPL workshop. We're using SES, so it's cloud managed. So all those attack vulnerabilities you don't have to worry about. But there should be an MCP server in here. And if not, then you can just install it. And then once you have it installed, you would go to apps. You could click on find more apps. And then from here, you could pull in the MCP server. I'll let it load. So if you type in MCP, and then here's the Splunk MCP server installed. And then if I click on the apps and go to the MCP server itself, let's try to find it here. There we go. You can see it'll give you the exact like endpoints, right? So I could copy this whole JSON, and then I could throw this into the text editor. So we'll just do new text document. Boom. And then all we're replacing is our token here. And then if we wanted to add a token, all we do is we go to settings, hit tokens. These are Splunk tokens. They're not even correlated to like any other. I mean, basically they're for the platform, but we can transcend them into the MCP server. And then you would create a token, new token, set your audience to MCP, hit create, and then you just copy this token here. You replace that with this your token, hit save, hit S, Oop, cancel. Okay, copy this whole file. Then you go back to your config, save that, and then you just restart Claude. So we quit, and then we'll restart it here. So you can do this at home. And then hopefully if it worked, we should go to connectors and we should see Splunk MCP server once it loads. We might have to do this a couple times. So we could hit quit again. Looks like we didn't save it, huh? File. So it's in the Claude folder. Hit save, replace, close out. Just hit don't save. Go back to Claude. And if it works, we should have that connector. Fortunately, it didn't. This is sometimes what happens. But those are the steps. And then from there, you could run a couple prompts. You could say like, from this incident, can you create an SPL to look at the breadth of this attack or to look at any lateral movement? So go back to that use cases slide. There's a lot of good Medium blogs that talk about it too. And start small. Start with the MCP server, then you can add in some other security platforms or tools, maybe observability tools, tracing tools, and then you can expand the scope there. Okay, cool. Well, thanks for your time, everyone. Thanks for joining me, and have a great rest of your day.